Hello. So I want to take a few minutes and go over today's activity, the slopes, triangles, and graphs, Desmos activity. So if you're watching this video, my guess is you might need a little bit of help. So here we go. Slide 1. Pretty easy slide to get from A to B. So if you look over here on the graph, you will notice A is here, B is here. We need to count blank units up and blank units to the right. So we are going to go ahead and draw our triangle just like we would do in class. Let me just make my font a little bigger. I would go up and then I would go over. And if you remember in class, we learned the up is 2 units and the over is 1, 2, 3. We count the squares. So I would count 2 units up, 3 units to the right. Now to get from B to C, it says sketch another slope triangle. I'm going to do the same thing. Here's B. Oops, let me get my pen tool. I'm going to sketch up. I'm going to sketch over. I'm going to go up 1, 2, 3, 4. So 4 units up and 1, 2, 3, 4, 5, 6. 6 units over. So I'm going to type my 4. I'm going to type my 6. I'm going to hit submit. Notice, same line, 2 different measurements we got for slope. And I've been telling you from the get-go, it doesn't matter which 2 points you pick. And here's why. We have these 2 steps, right? The slope from A to B, remember, slope is written as rise over run. So the rise for A is right here, and it was 2. So I'm going to click a 2. I'm going to hit my slash button. The rise for B is the run for B is this, and that was 3. Let me click in here and type a 3. And I want you to see I have this decimal there. Well, look over here now. Slope from B to C, the rise is 1, 2, 3, 4. So my rise is 4. My run is 1, 2, 3, 4, 5, 6, which is what we got on the last slide. So I'm going to type a 6. And now look, this decimal and this decimal, what do you notice about them? Good observation. So does it matter which 2 lines you use? No, because when you simplify the fractions, you end up with the same decimal because it's a linear equation. It's the same line. The slope cannot change. It has to stay the same or it wouldn't be linear. Constant rate of change. That's what we call linear, right? Now, sketch slope triangles. Doesn't matter where you sketch your triangle. You can sketch your triangle from Q to R. You can sketch a triangle from Q to S. You can sketch a triangle from R to T. Doesn't matter. You can go all the way from Q, which is here, all the way over to T. That's the one I'm going to do just because it's big. So let's count it out. I go 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8. So my rise is 8. Now what I want you to notice is look at this graph. Is this line going up or down? Remember we read a graph from left to right. So if I get on, yep, my line's going down. What does that mean for my rise? It's going to be a negative. And we counted 1, 2, 3, 4 over. So when I do my slope, I need to have a negative 8 over 4, which then takes me to a negative 2. If I would have done any other triangle, I would have gotten negative 2. If I would have done Q to R, be down 2 over 1, negative 2. If I would have done Q to S, it would have been down 1, 2, 3, 4, 5, 6. 1, 2, 3 over. 6 over 3 is also negative 2. So I'm going to submit, head over to slide 4. Same thing. Remember, and I know we still get stuck with this word clean points. Looking for dots on the line that where the line goes through the grid. So if I'm starting here and sliding down, this is not a clean point because it's not through a background grid corner. Neither is this one. This one right here, however, put a dot there. I can keep going down my line. Not here, not here. I want them where they're going to be whole numbers. That's one. There's one more on the line. Can you find it? It's right here. You only needed to find 2. I found 3. Doesn't matter where you put your triangle. Is the line going up or down? Well, yep, going down. So my rise is going to be negative. So I'm going to do the 2 close dots. There's my rise. There's my run. How many did we go down? Well, we went down 2. So that's a negative 2. We ran 3. So when I go to type my slope, negative 2 over 3. Pretty easy. Oops, what did I type? That is not right. Here we go. Submit. Done. Now look at slide 5. What do you notice? It says when you sketch a slope triangle, you're counting the change in y or the rise and the change in x or the run. What is the slope? Well, if I go from this point to this point, did I go up or down at all? Nope. So my rise is 0. How much did I run? My run was 1. Well, let's come over here to the calculator. If I type in the fraction 0 over 1, look at what it gives me for the slope. Yep. So what's our slope? Our slope is 0. Submit and explain. Well, it's 0 because when the rise is 0, the slope will be 0 because it does not go up or down. And then I'm going to hit submit. I have my evidence in the calculator. I have my evidence on the graph. And I'm going to move to slide 6. Same thing. Pick who's right. Kelly says the slope is 2. Shelly says negative 2. Ellie says 1/2. And Nellie says negative 1/2. What are the odds 4 friends all have names that rhyme? I don't know, but it's a story. It's fun to think about. Find points on the line. I will find the points for you. Here, 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 here. I found you 5. You only need 2. Draw your rise and your run. Is your line going up or down? Well, if I start here, yep, it's going up. So draw your rise going up, your run going over. Count it out, decide who's right. No matter who you pick, if I pick Kelly, or if I pick Shelly, or if I pick Ellie, or if I pick Nellie, no matter who I pick, you're going to need to explain why. Show evidence on your graph. Slide 7, there's not much to do. What I want you to notice is I want you to click this try it button right here. So when you push that button, what happens? Well, this goes up, a lever comes down, and watch what the little guy gets to do. He gets to slide down the slide. So fun. Let's head over to the next slide. Now, click try it again. Tell me what you notice about this slide. Yep, doesn't work, does it? Doesn't work because these 3 triangles do not have the same slope. Now, here's your goal. What I need you to pay attention to is this instruction right here. It says drag this black dot. Drag the black dot. You're going to raise this black dot up or down so that you can make a slope. If I don't move it at all and I hit try it, is it going to work? Nope. So I'm going to hit reset. I can move it a little bit. Is it going to work if I hit try it here? I'm getting closer. You need to move this black dot so that this slide works. You want the little guy to be able to slide into the water. Now, what I need you to notice about this, it says, here are the ramps from the previous screen that make a smooth slide. Why do you think these ramps lead to a smooth slide? Piece of advice number 1, give yourself 3 answers. Ramp 1, ramp 2, ramp 3. And you're going to give a slope for each one of these. On ramp 1, what's the slope? Well, remember, slope is rise over run. It's the up and down over the across. So the rise is here. The run is there. So for slope 1, the slope would be, or for ramp 1, the slope would be, well, the rise is 2, the run is 3. Find these two. What is slope 2? Or what is ramp 2? What is ramp 3? Ramp 2 is 6 over 9. Yep. Do the same thing for ramp 3. And why do they lead to the same one? None of them are the same numbers. Well, you're going to know why in a minute. Put all 3 of these slopes into your calculator and watch what happens. I'm not going to show you. I want you to do it yourself. Then go to slide. Oh, I should probably finish this one. You would say, these ramps lead to a smooth ride because they all have what in common? It'll have something to do with these numbers in your calculator. All right, 2 more slides to go. For slides 11 and 12, I need you to think back to 7th grade scale factor. Okay? In 7th grade, you learned that we could do something to numbers with similar triangles. For example, I could do something to 8 and make it equal 16. What would I do to 8 to get 16? Well, I'd multiply by 2. And if you look, the same thing would happen with ramp 1's thing. 6 to 12, well, it's times 2. So what you have to do on this slide is, if these are both times 2, how did I get from 8 to 24? What did I multiply by? Because that's the same thing you're going to multiply the 6 by. Well, 8 times what is 24? Guess what? 8 times 3 is 24. So what do I have to do to the 6 now? I have to do 6 times 3. And when I do 6 times 3, I don't get 30. What do I get? I get 18. When I click try it, my little man gets to go down the slide. Good job. Let me get my pen back. If it'll click again, clear my selection. You got one more slide to do. You're almost done. Scale factor again on this slide. How did you get from 10 to 30? That's what you'll have to do here. Okay, so you apply the same scale factor. Get the correct slides. When you have this correct and your guy gets up in the water, you are finished with this activity. Good job. Make sure that you have it all the way done because you are getting a grade. And happy math.